Hi everyone, it's Mrs. Martello. We're going to look at section 7.6 and we are on page 392. So in this section we're still going to factor, except now we're factoring an expression that has ax squared plus bx plus c. So now we're going to have an a value and a number in front of the x squared that's not equal to 1. And really not much changes, a little bit is different and it gets a little bit more challenging, but it's the same technique. So the first thing that we want to look for is to see if this a value creates a GCF. If it does, we're going to take that GCF out. If it doesn't, then we're going to factor it the same way that we did in 7.5. So I just wrote this down here so that we can kind of have an idea of what to do. So our first step is we're going to look to see if there's a GCF. If there is, we're going to take it out, and then we're going to factor the remaining polynomial. And we're going to make the table with the product sum and find our factors. So let's take a look at example 1. I'm getting this from the textbook here as example 1. We're going to do this one together and show our work a little bit more than what the textbook does here. So first thing we want to do is look to see if there is a GCF. And there is in this problem. There is a GCF. If I look at all three terms, we have 5, 15, and 10. All of them have a common factor of 5. And then if I look at the variables, this is x squared, this is x, but this term does not have a variable, so then there are no variable common factors. So it's just 5. We're just going to have 5. All right, so we're going to take 5 out of each of these terms here. So remember, we're going to divide this term by 5, this term by 5, and this term by 5. And that 5 is going to go in front of the parentheses. So this is going to become x squared plus 3x plus 2. Okay, this 5, the GCF, is just going to hang out in front here. And now we're going to factor this remaining polynomial here. This is our x squared term, this is our bx term, and this is our c term. So again, this is our x squared term, this is our bx term, and this is our c. We're going to make our table. Remember, we have our product is going to be x squared, the first term. Our second product is the c, that's the 2. And our sum is the bx term, that's our 3x. Remember, our sum is the outers plus the inners. All right, so we're going to break up x squared to be x times x. There's really only one way to get a product of 2. We need 1 times 2, and 1 plus 2 does add up to 3. So when I do my outers and my inners, this would be 2x plus 1x, or just x, which does equal 3x. So that does work out. All right, remember when I put this into my parentheses, these are my first and first. These are my last and last. This 5 is just going to hang out in front, and then I'm going to set up those two parentheses. In my first one, I have x and 1, so x plus 1. And then I have x and 2, so x plus 2. And this would be our expression just like that. So the only thing that changed is we first took out a GCF, then we factored this remaining polynomial inside of here. Okay, sometimes there is a GCF, sometimes there's not. So we're going to look at some other problems where maybe there's not a GCF. We're going to look at example 2. So here we have our ax squared, our bx, and our c. I'm just going to write down the general table here on the top just so that I always remember how to make the table. So to make the table, my product is ax squared. Remember our expression ax squared plus bx plus c. So our product is ax squared. Our second product is c. And our sum is bx. And remember, the sum is the outers plus the inners. So just keep that in mind when we're making our table. Okay, we're going to do example 2a. All right, so from the book, I have 4x squared plus 13x plus 3. 4x squared plus 13x plus 3. So from the last paper, our first step is to look for a GCF. Here, there is no GCF. They have no factors in common except for a number 1, which doesn't really help us. And they don't have a variable in common. This one doesn't have a variable, so no GCF. All right, so we're gonna make our table. So we have a product. Our ax squared term is this first term here. This is our ax squared term. That's gonna be 4x squared. Our second product is the c term. That's gonna be our 3. And our sum is the bx term, and that's gonna be the 13x. And don't forget, this is outers plus inners. Okay, now there are more possibilities with this because of this first term here being 4x squared. I could split this up to be x times 4x, that's one option, or I can also have 2x times 2x is another option. All right, and I want to figure out what's the best way to make this work that's going to give me a sum of 13 with my product of 3. So to have a product of 3, I know I need to choose 1 and 3. So let's see if I try 1 and 3 here. My outers would be 3x, my inners would be 4x, that would be 7x. That's not enough. What if I switch the order? What if I made it 3 times 1? Would that work? My outers would be 1x, and my inners would be 12x, and that does work. Okay, so this one is the one that works out. I didn't even have to try the 2x and the 2x. But if I tried it with 1 and 3, look at what happens. My outers would be 6x, my inners would be 2x, that would be 8x. That doesn't work. So this one did not work for us. It's this combination. So our outers would be 1x or x, plus my inners would be 12x, and that does give me 13x. Okay, I'm ready to set up my parentheses. Don't forget, this is the first and first, this is last and last. So my first parentheses is x plus 3, and my second parentheses is 4x plus 1. And that would be our answer just like that. Okay, we can always check our work to make sure that we got this correct. So why don't we show our check just to make sure. So to check, all I have to do is FOIL this out, and when I FOIL, I should get back this original expression from the beginning. So let's FOIL. First times first, x times 4x would be 4x squared. Outer, x times 1 would be plus x. Inner, 3 times 4x would be plus 12x. And last, 3 times 1 would be plus 3. If I combine these two like terms together, x and 12x makes 13x. And then I have the right expression, 4x squared plus 13x plus 3. So it does work. I know it works. Okay, let's do another one. We're going to look at 2b. So again, I'm just getting this from the textbook here. 3x squared minus 7x plus 2. 3x squared minus 7x plus 2. Okay, we're going to make our table because there is no GCF here. There's no greatest common factor between the numbers. This one doesn't have a variable, so no GCF. Let's make our table. We have our product. The first term is 3x squared. We have a product for our last term, which is 2. And we have a sum for our middle term, which is negative 7x. This is outers plus inners. Okay, let's figure this out. To get 3x squared, I know I need to use 1x or x and 3x. That's the only combination that I can split up the 3 into is 1 and 3 and then x and x. So I don't have two combinations like how I did in the first one, which it makes it a little bit easier. Now let's figure out the second part. If my product is 2, but my sum is negative 7, I need to have some negative numbers in there to give me a negative product. But in order to get, a negative sum. But in order to get a positive product, I need to have two negative numbers. Two negatives give me a positive. Okay, so let's figure this out. The only way to get a product of 2 is with 1 and 2. So if I have -1 times -2, let's try our outers, would be -2x, inners, -3x, that would be -5x. That doesn't work. Let's switch these around. Let's make it -2 and -1. Let's see if this works. Our outers would be -1x or -x, plus our inners would be -6x, and that does give me -7x. Okay, let's write our answer. Remember, this is the first, and this is the last and the last. So we're gonna have x minus 2 times 3x minus 1. And that would be our answer just like that. Okay, again, we can check our answer by foiling this out, and we can just do a mental FOIL with this one. Let's mentally FOIL it out. X times x is 3x squared. X and -1 is -x. -2 and 3x is -6x. So -1x and -6x is -7x. And then -2 times -1 is +2. So that one works out as well. Okay, we're gonna keep going. Let's take a look at example 3 next. Okay, we have example 3. We're gonna factor 2x squared minus 5x minus 7. Okay, first we wanna look to see if there's a GCF, and there is not. No GCF in this one. So we're gonna go ahead and make our table. We have our product for the first term is 2x squared. We have our product for the last term is -7. And our sum for the middle term is -5x. And remember, this is outers plus inners. Okay, let's find our numbers that we're looking for. To get a product of 2x squared, I need to do x times 2x. That's really the only combination it could be. And it doesn't matter if you wanted to do 2x first and x second, it doesn't make a difference. Next up, I need a -7 as a product. So in order to have a negative product, that means I need one negative number here. All right, so let's see. If I did -1 times +7, let's see if that would work. My outers would be 7x, and my inners would be -2. That would give me +5x, but I want -5. So let's switch which one is negative. I'm gonna make this a +1 and make this a -7. So my outers would be -7x, and my inners would be +2x, and that does give me -5x. Okay, we're ready to write our answer. So in our first parentheses, we have x plus 1, and then 2x minus 7. And that's our answer, just like that. Okay, let's keep going forward. Next, we're gonna look at example 4. So in example 4, we have our A term is gonna be negative. That's not allowed when we are factoring expressions. We need to have our A term positive. So when our A term is negative, our first step is we're gonna factor out a negative GCF. So if the GCF is 1, we'll factor out a -1, but if there's a bigger GCF, then we're gonna factor that out as well. So I'm gonna write that down here because it's really important. If A is negative, you must factor out a negative GCF because we need to have a positive A. We can't have A being negative. Okay, so if the a is negative, we're gonna factor out a negative GCF, and then we'll go ahead and factor by using the table. All right, so let's take a look at example 4. Let's see what that looks like. Okay, in example 4, we have negative 4x squared minus 8x plus 5. So we're gonna look for a negative GCF. In all of these terms, the only number that goes into all of these is 1, no variables, but I wanna make it a negative GCF, so let's take out a GCF of negative 1. Okay, if I take negative 1 out of each of these, I'm gonna divide it away. This becomes positive 4x squared. This becomes positive 8x, and this becomes negative 5. Okay, this negative 1 is just gonna hang out in front. Nothing's gonna happen to it. This is our new ax squared term. This is our new bx term, and this is our new c term. Okay, let's make our table. We have our product is 4x squared. Our second product is negative 5. And our sum is 8x. And again, this is outers plus our inners. Okay, let's figure out how to make this product work. So to get 4x squared, I could do x times 4x, or I could also do 2x times 2x. And it just depends on the problem, and I have to figure out which one works with this product to give me this sum. All right, let's start thinking about our second product. I need negative 5 because our product is negative. That means that I need one negative number here. All right, let's try it out. If I want to do negative 5, I could do negative 1 and positive 5. Let's try that. Our outers would be 5x. Our inners would be negative 4x, but that would be 1. That's not going to work. Even if I changed which one was negative, if this is positive and this is negative, that would just be negative 5x, and 4x would be negative 1. Let's try to switch these two numbers around. What if I put 5 first and 1 second? So let's do negative 5 times positive 1. This would be 1x, and negative 20x, that would be negative 19x. That doesn't work. What if I made this positive and this negative? That would be negative x, and 20x, that would be 19x. That doesn't work either. So it can't be this one. That's not the right combination. We need to do 2x and 2x. Okay, we know we need to get positive 8x here, so we'll make the bigger one positive. We'll do positive 5 and negative 1. Let's check. Our outers would be negative 2x, and our inners would be 10x. Negative 2x and 10x does make 8x, so that's the combination. Okay, so you see how I went through that trial and error of trying to figure out what combination it is, and that's just what you have to do just to figure it out and make it work. Okay, let's write our answer. We have 2x plus 5 in the first polynomial, and then 2x minus 1 in the second polynomial. The only thing I forgot here is my GCF. This negative 1 needs to be a part of my answer. I can't lose that. Negative 1 is a factor as well. So this answer has 3 factors. Negative 1 times the quantity of 2x plus 5 times 2x minus 1. Okay, so this is a big thing that I noticed. Don't lose that GCF in the front of the parentheses. Okay, we're gonna do some more just to make sure that we got this. Let's do some extra practice problems from monitoring progress. We're gonna look at monitoring progress number 1. We have 8x squared minus 56x plus 48. The first thing I want to do is look for a GCF, and actually this one does have a GCF. Look at these numbers. 8 goes into all of those numbers, so we're going to have a GCF of 8. Let's take 8 out. We're going to take out 8 and put it in front of the parentheses. So dividing each term by 8, this would be x squared minus 7x plus 6. Now we're going to factor this new expression inside of here by making our table. This is our x squared term, bx, and c. So we have a product of x squared. We have a product of 6. And we have a sum of negative 7x. Okay, for our x squared, there's only x times x. That's the only way. Let's think about our product. If it's going to be a positive product but a negative sum, I need 2 negative numbers, 2 negatives here. Okay, let's try -1 and -6. Let's do our outers would be -6x, and our inners would be -1x or -x, and that does work out. Okay, let's write our answer. Don't forget about our GCF in the front here. We're going to carry that and start with writing our parentheses, x minus 1 and x minus 6. Okay, that's number 1. Let's try number 3. 2x squared minus 7x plus 5. No GCF in this one, so I'm going to jump right in. Let's make our table. We have a product of 2x squared. We have a product of 5. And we have a sum of negative 7x. Okay, let's figure this out. I'm going to have x times 2x to get 2x squared. I'm going to again need 2 negative numbers here to get a negative sum but a positive product. So let's figure this out. If it's -1 and -5, let's see. Outers would be -5x. Inners would be -2x. And that does give me -7x. So let's write our answer. We have x minus 1 times 2x minus 5. Okay, let's do another one. We're going to look at number 5. All right, we have 4x squared minus 19x minus 5. All right, no GCF in this one. So we're going to start with making our table. We have our product is 4x squared. We have a product of -5. And we have a sum of -19x. Our product is negative this time, so this is one negative number. Okay, let's figure this out. For 4x squared, we can try x and 4x, or we can try 2x and 2x. It doesn't matter which one you try first, but there is one correct combination. So let's figure out which one we're going to do with this one. So to get -5, I know I need one negative number. Let's try -5 and +1. My outers, that would be 1x or x. My inners, that would be -20x. X minus 20x is 19x, so that does work. Okay, let's write our answer. X minus 5 times 4x plus 1. And that's our answer. Okay, let's do one more. We're going to look at number 7. Number 7, we have -2y squared minus 5y minus 3. Be careful with this one. Notice that your a is a negative number. Since our a is negative, we have to take out a GCF, a negative GCF. The only number that goes into all of these is 1, so let's take out a -1 for our GCF. So if I take out -1, it's just going to change the sign of all of these. So it'll be +2y squared plus 5y plus 3. This is our new expression. So now let's factor this expression in our table. Our product is 2y squared. Our second product is 3. And our sum is 5y. To get 2y squared, we're going to do y times 2y. To get 3, I know I have to do 1 and 3. Let's try 1 times 3. So my outers would be 3y, my inners would be 2y, and those do add up to 5y, so I found it. Okay, don't forget to carry down your GCF in your answer. This is -1 times y plus 1 times 2y plus 3. And that would be our answer to this question. Just be careful you don't lose that GCF in the beginning. That's a very common mistake that I notice.